Today we'll be talking about our 61850 Test Suite Pro tool. 61850 Test Suite Pro is our troubleshooting and diagnostic tool for 61850 environments or individual devices. Test Suite Pro can be used in the conceptual and design phase, factory acceptance testing, and commissioning and maintenance. During the conceptual and design phase, you can use a configuration of 61850 devices for Test Suite Pro to create automated tests to test your system. These tests can be reused during the factory acceptance tests when you have some IEDs in the lab, and during the commissioning and maintenance phases when all of the IEDs are in the substation. This is the GUI you'll see when you first open our 61850 Test Suite Pro. Test Suite Pro is our system diagnostic tools and can be used with individual 61850 devices or a full substation of devices. For this training, I'm going to be using DTM in the background. DTM is our system simulator tool that can simulate multiple IEDs and is instancing this substation here. I will be using this as the simulated environment in which Test Suite Pro will be acting and diagnosing and troubleshooting in. So for now I'll run this in the background, but we may see a few glimpses of this in future parts of this video. The first thing we're going to want to do is create a workspace in Test Suite Pro to match that of the workspace or the DTM substation it's in. To do that, we can click New Workspace or do File, New Workspace. Then we can provide devices in two different ways. We can either use Discovery across a range of IP addresses, or we can provide the SCL file. Since I have the SCL file for the devices I'm going to be connecting up to, I'm just going to go ahead and browse to that and select it. From here we can see all of the devices inside of that SCL file. We'll also notice all the IP addresses that these devices will be communicating on based on their configuration in their SCL file, and a green check mark indicates that a device is out and ready to be connected to. Regardless of if that device is simulated or physical, Test Suite Pro will try to reach out and connect to it. Since I am simulating the entire substation, we'll see they're all green check marks. If you see a red X there, do not worry. That either means your device is not up, simulated, turned on, or you need to change some configuration of your device. So to go ahead and add these devices, I'm just going to shift click and drag them all over. And now they're inside the workspace contents. I'll go ahead and give this a name. This can be our demo 61850 substation workspace. You can give an optional description. You can enable the IED simulator if you wish to simulate servers. You can enable the Goose publisher if you wish to push out Goose messages. You can select a client ID based on the SCL file you provided if you would like to have reserve report control blocks. Selecting a default Goose adapter will allow the devices you're simulating to default to a specific adapter for Goose. I'll select my Ethernet cable. And then, if you did need to make any changes to devices, you could right-click on them and do Edit Properties. At which point you would have access to the Goose adapter on the individual device level, the IP addresses, and any of the other information such as IPs or advanced if you'd like to drill down into that. I'm not going to change anything because I know the simulation I'm running and the devices I'm connected to are configured like this. I'm going to go ahead and click Save and Open. And now I've created my first workspace. Now Test Suite Pro is divided up into two different parts. On the left hand side here we have all of our tools under Tool Selection, and on the right hand side we have our displays. We're going to be looking at the tools right now to validate the configuration of Test Suite Pro compared to the devices that it's looking at. The first thing we'll notice is the system status, and it's got 19 warnings here. And the system status and everything underneath it is basically sanity tests that Test Suite Pro runs automatically for you. These 19 warnings or instances of warnings are letting us know that the devices are not connected currently. So we can go ahead and resolve that. We can go down to the advanced client, which we'll get to a little bit later, and go ahead and connect all clients. That will send a connection request out to all of our servers in our simulated DTM environment. And sure enough, now we'll see these have turned green. The green check mark here means that there are no issues to be worried about here, but we can still get some information off this first tool, the system status. First of all the IP addresses and the Goose adapters we're interacting with, if any reports have been enabled, Goose's subscription, events, things like that. Now let's take a look at the next one. Compare model will go out and look at all of the devices we're connected up to and perform a discovery on them, and compare the model that we're getting back to the SCL file that we provided. So for instance, if I look at this BCU and I do a compare, it will compare these, and then sure enough, since it is the same SCL file that I provided, we'll see that there is a match there. So knowing that there's no problems, I can always just come to these warnings and acknowledge them away, and that's done. The Goose Tracker is one of my favorite tools under this section. The Goose Tracker allows you to track down what Goose Stream's TSP is actually seeing as it is sniffing the wire, and comparing that to what it is expecting to see based on the SCL files you provided it. So for example, in this situation, all of these Goose Streams here were expected within the SCL file, so we got a match within the SCL and wire. Now, there are two possible situations that you could run into errors. Number one, you expect a Goose Stream, but Test Suite Pro does not see this. This can happen for various examples of various reasons, such as you forgot to turn on a device, or a device isn't goosing, it's not plugged in, so TSP expected to see a Goose Stream and it did not see it. Another example where this could be a problem would be Test Suite Pro was sniffing on the line and noticed a Goose Stream that you haven't had provided with the SCL files. This can mean Test Suite Pro is missing some SCL files that need to be added to the workspace so it knows more about your system, or you have left on a device or there is a rogue device in your system publishing Goose. Another way this comes in handy for us is we have a simulator tool that we'll be working with today, and occasionally we might have multiple people running the same simulation, or physical devices and simulation devices running at the same time. This can provide a duplicate on your Goose Stream, which can be very problematic when one stream, say the Goose's message is saying that the breaker is open, while another one, claiming to be the exact same thing, is saying the breaker is closed. So if you ever see a duplicate, you should track that down. Just like on the system status, there's a lot more information that you can look at, such as timeouts, retransmissions, state numbers, things along that line. It also will try to figure out where the Goose message is coming from based on your IP address and the MAC address, and then try to give you information. So if you do see a duplicate here, you might see one coming from Matt's ThinkPad and maybe another one coming from Matt's virtual machine. That would give me a heads up as to where to look for these duplicate messages. The LGOS tool will check the logical node LGOS in the device and figure out the status of the Goose Stream, whether the states of ST and SIM-ST are true or false. It'll also let you know if the devices were not connected, hence like what it looked like before we did the advanced client connection, or if there's no LGOS information at all. Currently everything is in a green state except for over here at this test subscriber who has a red block, which means that there is no SIM-ST being false and the ST is also false. Just a warning state, it's not necessarily an error, so we can move on. I'll go ahead and acknowledge these as well. The mod behavior and sim tool will allow you to change the mod or mode and the behavior of a device, as well as the streams that it is publishing, whether they are set as simulated or not. You can do this by going to your device and right-clicking it and changing lphd.sim, or going down to the individual nodes here and changing the mod. This is how you can do things like digital isolation and testing devices without necessarily acting and changing their output. For example, if I went to change this value here, this is the control value of the mod or mode, we could set that to blocked. So that way it performs as if it is in a normal state, but all of its physical output to the electrical equipment will be blocked. Or you can change it to test or test block, allowing it only to accept test signals. The last tool in the system status that we'll be looking at is SCL Verify. SCL Verify will allow you to select the SCL file that you provided, and it will give you our first look at a display which is all of the actual lines of the SCL file that you provided, as well as you can run SCL verify on it, and it will let you know if there are errors, warnings, recommendations, etc. So, once we have taken a look at all of this and we've confirmed that our system is set up properly, we can start diving into the more advanced tools in the tool section. We've already taken a little bit of a look at the advanced client, so I'll go back into that. The advanced client will allow you to select one of the IEDs, masters or clients that you're simulating in Test Suite Pro, and look at the model. So we can look at this BCU here and see there's a measurement and control logical device in it. I can open that up, and then we see all of our logical nodes. This is the measurement, so we can look at the MMXU. Inside of that we have our amps, phase A through phase C, the instantaneous, and the current value. So you can really drill down into these and look at the values. You can also see here how the data is getting across the line. So for instance, the magnitude of this phase A current is coming in as a report. The key for what these little symbols mean is up here at the top. So if we were getting them in by goose, it would upgrade to this little value here, or if we were just doing polling, it would be a P. Of course, you could go in here and right click on things and perform reads and writes. You can start polling. Anything that you can do from the master, you'll be able to do from the advanced client here. And of course, you have access to all of the devices in your Test Suite Pro workspace. If configured, you can go into your logging services here and configure the device and what range of time you'd like to look at your logs according to your entry ID and whatnot that you have set up. And you can also test out file services by uploading and downloading different files to the server. The next thing we're going to be looking at is the Goose Publisher. The Goose Publisher is a way to simulate Goose messages that Test Suite Pro knows should be on the line that isn't necessarily on the line currently. So, if instead of having to purchase a device and running that device in the network where you're trying to test a configuration or something, we can have Test Suite Pro send out a Goose stream without a server. To do that, you would just select the adapter that you wish to send your Goose message out on, and then you can go into this organization here, see it's organized by Bay and then IED, so I could go into this BCU, open that up, see all the values that are expected within the stream of the BCU, and simply just click the play button here. Since I'm already simulating this stream on my DTM software, this would cause a duplicate, as I mentioned before, which could be problematic. But if I didn't have DTM, or if I just need to simulate a missing or broken or in maintenance device, this is a quick way around being able to set things up and run tests. We can also take a look at the IED simulator. The IED simulator is very similar to the advanced client, but it will be used on the server side. The server can be selected from here, just like you would with the advanced client, and then simply clicking start will start a simulated server within Test Suite Pro. This feature can be used if you are trying to test an individual device, such as a HMI or a 61850 client, and you need a simulated 61850 server changing data or being receptive to controls and commands. So this goes over all the basic features of our tools. The next thing we'll be taking a look at is our displays over on the right-hand side. And the displays are eventually built up using this data miner tool. The data miner tool will go over in a little bit more detail in the next section of this video. Now that we're in the displays section, I do want to talk about one more tool. And the reason I'm talking about this tool in the displays section is because this tool is used to create a lot of our displays. The last tool we'll be looking at is the data miner. The data miner takes the model view of all of our devices and compresses that down into a flat view. The flat view can just be seen as a table. That being said, by default we do have some groups and some filters that you can put on to locate the data you're looking for. For instance, if I'm interested in line 1, I can go inside of that grouping, and then we've got things organized by the logical name and the logical node. Inside of that we can see some things like interlocking switchgear on different areas. We have the data objects here, and you'll notice the value is not necessarily corresponding with the data object. That's because this data object has more than just the values, such as the quality and timestamp. From here, you can find the features of the functionality you're looking for and drag them over to specific displays. So, let's take a look at what some of those displays are. We could have something similar to the custom display, which we like to use as the single line diagram. This is a reflection of all of the client databases across our workspace. We have been able to build up a replication of the single line diagram, especially that you could see in DTM, such as this, but this time inside of our client tool. This becomes even more helpful when you're interacting with physical devices, and you won't necessarily have a single line diagram to look at, such as our simulator tool. Now, how do you build this up? You can just grab things from the palette, such as a bus bar, and then maybe come over here and grab one of our positions and drag that over from the data miner, and then we can build in additional pieces to this. Of course, you can have as many single line diagrams or custom displays as you want. We currently have one as a single line overview, but then you can zoom in to say line 1 and get more information. As you can see, we've gone more in depth into line 1 here, including the ability to send open controls to each of the switches and to the breaker, and any of the values coming across, such as the voltages here you can see in 3-phase. Another one of the features that can use the data miner is the logic analyzer. The logic analyzer allows you to grab the values that you're interested in from the data miner and drag it over into this selected signals diagram. And each of these signals will then be shown up down here. And we can get a little bit into more detail of what this looks like once I actually record some data in it. The signal flow is another one that can use the data miner. The signal flow shows how values and data is transferred around through your system. So let's go ahead and start recording some data, and we'll be able to see how these displays work. So I'm going to go ahead and click record on the signal flow here, and then I'm going to go back to my simulation, or you would go to your physical devices and trigger an event. Like the previous video, I'm going to go ahead and trigger a fault on line 1, and all we saw was that breaker open and close. But let's go see what Test Suite Pro came across with this. Test Suite Pro has recorded 10 different events that happened in that situations. Let's step through and see what happens. The first thing it noticed was the differential fault was detected. That was what I clicked. That differential fault and any other source of fault are all being multiplexed into a PTRC. That PTRC is sending a message both internally inside of the LPU and externally via Goose to our SCU. After this, you can see that the SCU responds by the breaker opening as a response to the fault. Then you can continue to click through and monitor everything else that happened in series. You can play it back one at a time, or you can step through them individually. As for the logic analyzer, we can go there and we can take a look at what would have recorded if we had done that. In this recording, we can see exactly what happened when the reclosing event happens. So, if we look in here, we'll see a few events have occurred. Let me zoom in a little bit. We can see this is the P differential, and then this is the PTRC. So once the fault was noticed, the rising edge of this triggered the rising edge of the PTRC, which caused the breaker to go open. So one useful metric of this might be, when was the fault detected, and what's the differential to that for when the breaker actually finally opened? And we can see up here that it was 80 milliseconds from when the fault was detected and the breaker was open. This is the type of logical diagram you can look at with the logic analyzer. Of course, while that was happening, our custom display here would have shown this breaker going open and closing. And so those are the first 3 displays we're looking at. The next thing we've already looked at was the SCL viewer. This just allows you to take a look at the viewing, take a look at the SCL file that you are adding to Test Suite Pro. And then the next thing that you'll want to look at is one of the tools I think gets used quite frequently would be the report viewer and the Goose viewer. The report viewer will actually go ahead and track any of the reports that any of your masters have pulled. So, for example, if I look in here, we can look at some of the data changes that happened during that event. So I can click on it and actually let's get a little bit more real estate here. Look to see inside of the most recent, or sorry, the first report since I started recording had the P differential general at true. And of course, you can multi-select these guys and look at them side by side and see what changed in between each of these reports, allowing you to see there was a trip from the protection, the fault was disappeared, a wait, and then the circuit breaker reclosed. So you can actually take a look at all of the historical data that was sent across the line via report. Following that same logic, you can look at the Goose Viewer. The Goose Viewer is looking at the Goose streams and the states as they are updated. And following that same logic, you can multi-select to look at multiple of them, you can go across different Goose control blocks, and you can look at the historical data here as well. The server data simulation is used in conjunction with our IED simulator. This allows you to, when simulating a IED, it is very similar to the auto data change feature within our DTM product. This will allow you to not have to go in and manually change things by hand in the IED simulator, but actually go through and add individual points and change those, say, per second, per minute, every 2 seconds, whatever interval you put in here. This will cause lots of traffic to be generated and allow you to do performance tests and things like that on your client if your client is under test. And then the last thing I wanted to point out is our test sequencer. This is where a lot of our automated tests are actually going to be set up. Once you have your system configured properly and you have everything how you'd like it, you want to set up automated tests. This is kind of a callback to what I was mentioning at the very beginning of the video, where you could set up automated tests within the within the conceptual and design phase that you can use through the commissioning and maintenance phase. So for instance, we do have this one test set up here, but you can also go through and check out each of the individual tests for this display. So what is this display right here? Well, it is showing you individual test steps that are happening. So during the setup phase, you can come in and go inside of this and get an alarm here. So this is a user action, the second step, and it is ensure that your breaker is open in the custom display for line 1. This is a user prompt, so you can tell your user, go flip a switch, turn on the device, go change this variable, etc., etc. Then the next step here is another one. It tells you to go start a recording in the signal flow. So if you'd like to have a historical log in the signal flow, you want to make sure to click this button. It'll go ahead and gather all those signals. We can go to the test sequencer here. Then it's actually going to perform an operate. It's going to set line 1 BCU, the phd.sim, to true, and the control mode to test. So the point of this test is to virtually isolate the BCU. So if you go into here, you'll actually see that this isn't asking the user to anything. This is something, an operate that Test Suite Pro is doing. So it is going to perform an operation, and that operation is setting lphd.sim.stval to on, and lln0, the mode of that, to test. When these are completed and issued, we're going to verify that the server actually took it. So we can go in, do a verify step, and validate that those changes actually took place. It's going to step through each of these individual tests until we get to the end and let us know where it either fails or if it was successful all the way through. And you can set up an entire suite of tests over here on the right hand side to allow you to set up these automated tests. Then it's just as simple as running all of your tests, making sure you've got your initial conditions set up, interacting with any user actions as they pop up and occur, and you can run through all of your suite of individual test cases for your system.